So this is the complete project report or complete project file for Computer Architecture and Organizations Lab for registration number 25 MCA003. My name is Akash Tiwari and I'm going to build and run this project. So we will start with building the solution. The solution is built successfully. Now we are going to debug it. Let's start with debugging. Okay, so we will maximize the section. We will check with every option and let's see if it is working fine or not. So we'll check with option number 1, exit. It is working perfectly fine. We'll go with local Windows debugger this time. Okay, now we'll go with option number 2. This is for parallel construct program. First we will check with the serial. It is splitting hello world only once. We take parallel. It is splitting hello world parallel to the number of times to the number of cores. 2 3 for both serial and parallel, and 2 0 for exit. We'll check with the runtime environment routines 3. We'll go with the performance analysis. 311 for serial. So here it is done by thread ID 0. We will go with parallel 312. There are 12 cores in my system, and you can see there are almost 12 threads assigned to the process, and 313 for both. This is for serial, this is for serial, this is for parallel. Exit. We will go with runtime environment routines. We'll set the number of threads first. 6. You can see the number of threads is set. 3 2 2. We have set the number of threads 2, so we will get the number of threads 1 for this process. 3 2 3. Okay, the maximum number of threads in my system 12 ports, 12 threads. Get the thread number 324 0. Current thread number is 0. 325. The number of processes. Sorry, 325. Yeah, so number of threads and number of processes 12. 326. So 12 ports, 12 parallel regions. Okay, 327. 328. Setting the dynamic thread to 0. 329. Nested thread to 1. Get the number of nested threads 3210. Nested parallel 0. So we will exit this now. Exit this. Third runtime environment done. Fourth loop work sharing constructs. 4 1 serial. So in the serial code, this is how the execution is happening. You will see for the parallel region, for the parallel construct. So we can see the number of we can see the thread ID, the ID of the thread, and what it has performed. Now we will see for both. So here it is for parallel, and here is for serial. The difference is you can see here the thread number. Here there is no thread number. Exit the solution. Fifth, 5 and serial. And see the serial code. 5 2 for parallel. You can see the shuffling is different here. 5 3 for both. So here it is for serial and for parallel. You can see there is a difference. 5 0 exit. 6 for scheduling. 6 1 for static scheduling. We will go with the default static scheduling. We are not going to set the number of we are not going to set the chunk size. So you can see the system is randomly allocating the chunk size. 6 1 2 allocating the chunk size to them. So here minimum, so here you can see the chunk size is different, and 613. So here the chunk size is set to be 2. 610. Exit. We'll go with dynamic scheduling this time. 6 to 1. We have set the chunk size to be 1. So you can see each thread gets minimum number of chunks to be 1, and the thread 0 does most of the operation. Then thread 3, because minimum is 1, so it gets minimum one thread, and one thread for 2 and 1 as well. Now we will set the chunk size to 2. As you can see, 2 and 3, both 2, 3, 1 and 0 gets minimum chunk size to 2, but thread 0 does most of the work, then thread 2, then thread 3. Exit. Uh, Guided. We will set the chunk size to 1. Use the output for chunk size to 1. 632. Use the output for chunk size set to be 2. We will exit. 602. Exit this scheduling system. Uh, so scheduling construct is done. 7th is data environment constructs. 7.1 is for shared and private clauses. So in the code we have uh, coded it in such a way that it does the vector addition using the shared and private clauses, where there is a copy created for shared and private constructs. Uh, so this is the output for serial code. We will check for parallel. So you can see the answer is same, but here it is done in serial manner, but here it is done by parallel number of threads. Okay, this is for both. So, 7172 for critical section. 721. So you can see for a critical section only one thread can enter at one time. So thread 0 is entering and it is doing all the same. And now we will do for parallel. So you can see there are different threads entering into the critical section and performing the operation in a synchronized way. 7 2 3 for both. And then we will exit. We will go with the reduction clause. 731 serial. So here it is working in serial manner. 732 for parallel. So here using reduction clause, you can using the critical construct, only one thread can enter into the critical section, and it somehow reduces the efficiency of the program. But using reduction clause, we can still get the code to power up using the critical section, as well as enter parallelly and perform the operation. So both are done, and 730 to exit, and 700 to exit the workshop machine. Thank you. This is the we will end with exit 1 equal with exit.